So we're going to factor the following completely. 4x squared minus 25 is the difference of squares. So if I square root 4x squared, I should get a equals 2x and b equals plus or minus 5. So my factors are going to be 2x plus 5 and 2x minus 5. Let's see if I can move this. There we go. Okay. Bring it back down. Okay, so for number 2, x squared plus 8, x squared plus 8x plus 12, I'm going to factor this to x plus 6, x plus 2. 3x squared minus x minus 2, the product of 3 and negative 2 is negative 6. My factors of negative 6 that would give me 1, or negative 1, would be negative 3 and positive 2. So I'm going to break this up into those two factors. I get negative 3x plus 2x, and then I'll bring down my negative 2 and my 3x squared. So if I group these together, I can factor out a 3x here and a 2 here. So I get 3x times x minus 1 plus 2 times x minus 1. So those are the products of the distributed factor. So if I bring these together, I get 3x plus 2 and x minus 1. Number 4, I can factor out of 8 and 2, I can factor out of 2, x to the 4th and x squared, I can factor out an x squared. I have 4x squared plus 1. Since 4x squared plus 1 is the sum of squares, I can't factor it further, so this would be my solution, or my factors. Out of 8, 16, and 10, I can factor out a 2. X cubed, x, and x, I can factor out a 2x, or just an x. So I'm left with 4x squared plus 8x minus 5. 4x squared, 8x, and negative 5. 4 and negative 5 equals negative 20. To factor this out, I get negative 2 and positive 10. So I'm going to break that up. My 8x, my negative 2 would factor best with 4 and not 5, so I'll do negative 2x plus 10x minus 5, and then 4x squared. I'm going to factor the GCF out of these two groups. I get 2x, and this one will be 5. So I have 2x times 2x minus 1 plus 5 times 2x minus 1. If I put my multiples together here, I get 2x plus 5, 2x minus 1. I can't forget about the factor that I already brought out, so I'm going to bring down my 2x to in front of my two factors. So it's important to remember when we're talking about factoring that we're talking about the product. So after we've factored, what you're looking for is you're rewriting an expression as the product of factors. And product, remember, is the so if you're multiplying, the answer is a product. So the expression as a product of two factors. Sorry, just of factors. So product and factors. Terminology-wise, we have function. So we have polynomial function, which is your x squared plus bx plus c. And your factors are, after you factor it out, this is the product of your factors. So this multiplication here is what's important. A rational function, the word rational has this word ratio in it, which we know is a fraction expressing a proportional relationship. And so A rational function is going to be a function defined by a rational expression. In terms of what we're looking for with these polynomials, the way we represent this is r of x, which means our rational function is the ratio of p of x to q of x. And we know that q of x, because it is in the denominator of the fraction, cannot equal 0. P of x and q of x are both polynomials, are polynomial functions. And you will see what that looks like in a second. Okay, go ahead and pause the video and copy down this little setup that I have here, and then go ahead and come back to the video. Okay, so I'm going to draw an imaginary line, an imaginary vertical line here at x equals 2. So this x equals 2 vertical line is imaginary, that's why I made it dashed. Okay, if I draw a function that follows the same path but never touches the x-axis and never touches the y-axis, we'll figure out what kind of graph this is later. But what we're looking at here is that for every x value, there is a y value, which means that we have the function. So there is a y value, except. So if that function never actually touches that x equals 2 line, we have a y value for every x input except x equals 2. So graphically, what this looks like is the domain is all numbers, is all values of x, except that x equals 2. If we write this in set notation, we get the values of x such that x is all real numbers except x is not equal to 2. Algebraically, so if we're looking at a graph and we have the purple function going towards that x equals 2 vertical line, but it never actually touches it, so it gets infinitely close. What we're looking at, if we put it in a calculator, is we would get some kind of undefined or error message in the calculator if we put 2 into whatever function created that purple graph. So algebraically, to connect the dots is when the denominator of a function is 0. So when the denominator of a function is 0, the function is undefined. Oh gosh, come back. So again, you put that in your calculator, you're going to get an error message. You're going to get some kind of x equals 2 does not have a y value. If we put this in terms of algebra, then we're looking at a denominator where the denominator equals 0, so x equals 2. The domain would be values of x such that x cannot equal 2. So the relationship between the graph in the algebra is input values of x would give you any of the purple graph except 2. So to find the domain of the following rational functions, if we're looking at the domain, okay, remember the domain is your x values. So if we're looking for x values that exist, we're looking for the domain where the x values don't exist. In other words, what we're going to do is set the denominator equal to 0 and then solve. So we're using the zero product property here. 5x equals 0, so x equals 0. The domain is all values of x except x equals 0. So this is in set notation. The denominator, x minus 2, equals 0, so x equals positive 2. The domain of this function would be values of x where x does not equal 2. So it's all values of x where x does not equal 2. For number 3, we would have two x values where the function would be undefined. We have x is negative 3 and x equals 1. So the domain is going to be values of x where x does not equal negative 3 or 1. So you want to write them in least to greatest with a comma in between. A simplified form of a rational expression means that we have no common factors except for 1. In the numerator and the denominator. I'm going to show you an example of this with numbers before I give you the 3 steps. So if I have, let's see here, I have 2 times 3 times 4 over 2 times 5 times 1. Common factors, if I'm reducing, means that I'm getting rid of these multiples where they appear in the numerator and the denominator. So the only common factors that I got rid of were 2 and 2. 3, 4, 5, and 1 are not common. So if I multiply those together, the simplified form of this would be 12 over 5. Okay. So in terms of that, the first step when we're looking at polynomial functions is you're going to factor both polynomials. So factor all polynomials, which means we're going to factor the polynomials in the numerator and the denominator. And then my second step is to find the domain, and you're going to use the original function or the original factors of the polynomial to find the domain before canceling, before simplifying. And then step 3 is to cancel your common factors. Just like I canceled the 2 and 2 of the fraction to the right. Okay, so to simplify the following, state the domain in set notation. So I'm going to set the denominators equal to 0 after I factor. So I need to factor first. My first step here, x squared, 7x, and 10, I get x plus 2, x plus 5. X squared minus 4 factors to x plus 2, x minus 2. And I know that I factored this correctly because I have a common factor in the numerator and the denominator. My second step is to find the domain. I'm going to set x plus 2 and x minus 2 equal to 0. My x values are plus or minus 2. Step 3 is going to be cancel common factors. So cancel your common factors. Try and do it in different colors so that you can identify what you're canceling. X plus 2 and x plus 2. This leaves me with the ratio x plus 5 over x minus 2. So the answer is x plus 5 over x minus 2 with the restrained domain restrictions for x values that cannot equal plus or minus 2. For number 2, I'm going to factor x plus 5, or x squared plus 5x plus 4. So I get x plus 1, x plus 4. And then my denominator, I have this negative 12 here as my c term. So negative 12 can be either 2 and 6 or 3 and 4. Sometimes it's easier to just think of our multiples of 2. And so if you're picking 2 and 6, if we did x plus 2, x plus 6. X plus 2 and x plus 6 do not have any relatable common factors in the numerator, so I know that's not going to work. So when you have no common factors, you need to go back and refactor. No common factor, redo. So I know that 3 and 4 minus 3 is going to give me the correct factor here. So if I have x minus 3, x plus 4, I'm comfortable with that factoring because I have two common factors in the numerator and the denominator. To find my domain, I have x minus 3, x plus 4 equal to 0. So x equals 3 and negative 4. Step 3 is to go and cancel my common factors. So I'm going to cancel those and I'm left with the ratio x plus 1 over x minus 3. So my answer is x plus 1 over x minus 3 for values of x that do not equal negative 4 or 3. Number 3, 4x squared minus 1. I can square root both the 4x squared and the 1. It is the difference of squares. So I get 2x plus 1, 2x minus 1. When you have a denominator or a numerator that is a trinomial with a leading coefficient or some kind of grouping like in question 4, you want to do it to the side so that you don't get a bunch of mess in your denominator. You want to make sure that you have a clean denominator and a clean numerator for your canceling. So if we have 6x squared plus 5x minus 4. 6 times negative 4 is negative 24. My factors of negative 24 that will get me to negative 5 are going to be, positive 5 are going to be negative 3 and positive 8. 8 minus 3 is 5. 8 times negative 3 is negative 24. So when I look at this, 6 and 4 need to be grouped with the correct factor. So negative 3 factors from 6 much easier than 8. So I'm going to break this up into negative 3x plus 8x. And I'm going to bring down the rest of my equation. So I have 6x squared. I'm going to group these together, and I'm going to factor out a 3x from here, and I'm going to factor out a 4 here. So I get 3x times 2x minus 1 plus 4 times 2x minus 1. That's the product of the factor being distributed. So I want 3x plus 4 as my first term, or first polynomial, and then 2x minus 1. I feel comfortable that I have a correct factoring there because 2x minus 1 and 2x minus 1 both appear in the numerator and denominator. So I have 3x plus 4 and 2x minus 1. So my domain is where 3x plus 4 and 2x minus 1 equals 0. So x equals negative 4/3 and x equals positive 1/2. When I cancel my common factors, I'm left with the ratio 2x minus 1 over 3x plus 4. So I have 2x plus 1 over 3x plus 4. for my values of x that do not equal -4/3 or 1/2. All right, number 4, we have 3x squared minus 24x. My numerator, I can factor out 3x from both of those terms. I get x minus 8. I have a pretty heavy trinomial in the denominator, so I'm going to factor that out. I get 3x x squared minus 5x minus 24. X squared minus 5x minus 24 will factor to x plus 5. Sorry, x plus 3. X plus 3, x minus 8. So this will be my denominator. I get 3x, x minus 8, x plus 5. It doesn't matter what order. Why does that keep doing that? It should be x plus 3. X plus 3, come on, pen. That's a plus. Okay, x minus 8, x plus 3. To find my domain, I'm going to set that denominator equal to 0, and I'm going to figure out which values of x would make it equal 0. So I have x equals 0, x equals 8, and x equals -3. This means that we have 3 undefined vertical lines on our graph. Last step is to cancel. So I have a 3x, 3x, x minus 8, and x minus 8. It looks like we might not have anything left in the numerator, but we do have a positive 1. So the answer is 1 over x plus 3. That's a 1, not a 3. We have x plus 3 for our values of x that do not equal -3, 0, or 8. If you're wondering if you have to include this slash mark between your x or between your equal, you do, because what you're representing is values that do not exist. So x that is not, or x that is except -3, 0, or 8. All right, guys, last 2 questions. So for number 5 and 6, we're kind of going backwards in our understanding of how to do these polynomials, or how to simplify these rational expressions with polynomials. So we're creating a rational function. So we're going to create something that is r of x equals p of x over q of x, where we know p of x and q of x are both quadratic functions, or just functions in general, polynomial functions. The numerator and denominator need to be quadratic functions. So we want something that's x squared plus bx plus c. We do know what quadratic functions look like, and if we're reducing to x plus 6 over x minus 6, I'm going to go back to, let's look at question 2. So we reduced to a ratio with an x plus 1 and x minus 3 in the denominator. So we're starting with this simplified form, and we need to go backwards. And so if we're going backwards, we're going to multiply the numerator and denominator by a factor that would be cancelable, or in other terms, the same factor. So if we have x plus 6 and x minus 2, this is our simplified form. I would like to multiply the numerator and denominator by the common factor, x minus 3, because I know that those would cancel. So we have, this is factored. We want quadratic. So we want a quadratic function, which means we need to multiply our factors back together. So we have x squared plus 3x minus 18 over x squared minus 5x plus 6. So we have 2 quadratics, numerator and denominator, that are multiplied back together. So we went in the reverse order. Last question. We're going to write a rational function that has the following restrictions on the domain. If we have restrictions on the domain, we're looking for a denominator that has two factors in which the restrictions would be x equals -4 and x equals 1. So we have x plus 4, x minus 1. This is going to be our denominator. So I'm going to create a denominator, x plus 4, x minus 1. We don't have to cancel anything, so I'm just going to write x plus 2, x minus 8 in the numerator, pretending like I already canceled common factors. So I have x squared minus 6x plus 6, or sorry, it should be minus 16, over x squared plus 3x minus 4.